So the question says, using an equilateral triangle, show how to get sine theta, cos theta, and tan theta equals to 0, 30 degrees, and 60 degrees. So it's more like asking us, I'm talking about question 4. It's asking us to show how to get sine 30, cos 30, tan 30, how to get sine 60, cos 60, tan 60. So for us to do this, let's say this is our equilateral triangle. So an equilateral triangle, we know that the sum of angles in a triangle is 180. So we're having here to be 60, having here to be 16 degrees, 16 degrees, having here as well to be 60 degrees. Then notice that if you divide this way is right angle, this way is right angle. So the angle here is 30 degrees, 30 degrees, making it 60. So if I know this, so it's more like I now have 60 degrees, 30 degrees this side, 60 degrees, 30 degrees this side. So let's say I call here A, sorry, let's say I call here A, call here B, call here C. If I choose to call here A, so that means that all of here is A, this is B, this is C. So let's say I call here H for height, the height. So if I want to do the sine of the 60 now, so if I want to do the sine of the 60 now, so watch, notice that this is going to be, on this part I have 60 degrees for B, I have 60 degrees for C, I have 30 degrees for A, 30 degrees for A in two places. So you can see that by the time you put these two angles together, it's now giving you that of double angle. So but when I'm considering just one of these, so you see that, for example, if I want to do now sine A, so sine A is the same thing as saying 30 plus 30. That is, sorry, yes, A itself is the same thing as saying 30 plus 30. YB is having angle 60 degrees. YC is having angle 60 degrees. So remembering what we know about sine, they say sine theta. Sine theta is equals to opposite over hypotenuse. So that means that you cannot do sine of an angle with equilateral triangle. To do sine of an angle, you must make it to be in right angle. So this sine talks about when the angle is in right angle, and it talks about opposite, talks about the opposite side over the hypotenuse. Understand? This is the hypotenuse. This is the opposite side. That is for this angle. If there's an angle here, one, if I have an angle this way, if I have an angle, let's call this alpha. If I have an angle this way, this side becomes the opposite. This side becomes the hypotenuse. So the side facing the angle is always the opposite. So y for cos theta, if I have an angle this way, adjacent over hypotenuse, adjacent over hypotenuse. And if I have an angle this way, this side becomes the adjacent over the hypotenuse. So the side that the angle is sitting on is always the adjacent. Y tan theta, so adjacent over y tan theta will always be sine theta over cos theta, or you say it will always be the same thing as y over x, or you say it will always be the same thing as saying the numerator of the sine, numerator, whatever you see on the numerator of the sine, all over whatever you see numerator of the cos, because the denominator will always be the same. So if I know this, let's now try to do this. So notice that when I'm talking about for this, if I come here now, when I'm talking about sine B, I'm talking about sine B, and notice that the angle in sine B is 60 degrees. So it's the same thing as saying sine 60 degrees will be equals to opposite here, h over hypotenuse. Hypotenuse is this side. So but notice I think the first thing I need to do now, or the first thing I should have done, is to remind you that if this is an equilateral triangle, the sides should be equal. So let's say I call this side, this part, this is like 1/2. So let's say I call this side 2. I'm using 2 so that I can call this side also 2 and call this side also 2. So now notice that the sides are equal. If I use 1, it's still the same thing, but it's just that I will now come and say half. But it's better I do just this side is 1, this side is 1. So with whatever you use, so far as it's equal, no problem. So notice that I have 2 this side, I have 2 this side. So I have 1 this side, I have 1 this side. If you like, close your brain and be arguing. If you pay attention to what I've done here, you see that the sides of an equilateral triangle are equal. And the angles are equal to 60 degrees. So if I know this, looking at this now, this particular part, which is h, I don't know it, but I know this to be 2, and this side is divided into 2, right angle, 1, 1. So now notice for sine 60 is going to be opposite h over hypotenuse over 2. And another thing I want you to know is that no matter what happens, the hypotenuse is always positive. Always positive. The hypotenuse is always positive. So if I know this, you will now see that this is now going to be the same thing as saying, okay, sine 60 degrees, yes. I have gotten 60 to be opposite over hypotenuse, which is sine 60 opposite h over hypotenuse. Okay, yes. Then for sine 30, I'm leaving it at this. I'm not rushing. For sine 30, this is 30 degrees. This is 30 degrees. So for sine 30 degrees, this is also 30 degrees. So you see that this is going to be the opposite. This way, if I'm looking this way, look at where my biro is. Looking this way, this is the opposite over hypotenuse, 1/2. Opposite over hypotenuse, 1/2. So for sine 30 degrees, I'm going to have opposite is 1 all over 2, half. 1/2. Okay. Notice that this one is still having h this way. Okay. What about cos 30 degrees, since I've done this now? So if I know this now, that this is 1/2, this is 1/2, I can actually say, okay, at this point where I have this, let me do cos 30 degrees. Cos 30 degrees will simply be, this is adjacent over hypotenuse. So cos 30 degrees will simply be h all over 2. That is cos 30 degrees. This is 30, this is 30. This is the adjacent side, the side the angle is sitting on, adjacent over hypotenuse all over this. So now that I know this, I don't want to be carrying h. There's nothing like h. But we can go to Pythagoras. And remember that Pythagoras gives us that the hypotenuse square is equals to, that is the hypotenuse square is equals to x-axis square plus y-axis square. Now notice that from this triangle, this side now, the hypotenuse is 2 square. Then this is 1. Once that is x side equals to 1 square plus y-axis. I don't know it, so let me call it h square. By the time I do this, this is going to be 4 equals to 1 plus h square. And you see that this is going to be the same thing as saying cross over 4 minus 1 equals to h square. It's going to be 3 equals to h square. So h is equals to, when square cross equality sign, it becomes square root of 3. So root 3. So why I took my time to do this one step at a time is to see that there is no memorization or cramming to it. Things work out because you use Pythagoras theorem. And whenever you're talking about right angle, triangle, when you've divided this. I told you that sine and cos only work on right angle triangle. The equilateral helps us get the angles divided into 60 degrees, and knowing that each side should be equal, I'm using 2. If you want to use 3, no problem, provided you still remember that what you have here should be equal to giving you the whole sides. Which is this side are equal. So if I know this, I've gotten h. So h is equals to root 3. H is equals to root 3. Now that I've gotten this to be root 3, I'll come here and replace this. So this is the sentence saying that cos 30 degrees is root 3 over 2. And this is the sentence saying that sine 60 degrees is the sentence saying root 3 over 2. Now let's move to cos 60 degrees. So cos 60 degrees now will be equals to, notice that this triangle and this right angle triangle, they are the same thing. But I'm using the 2 since we are talking about equilateral triangle, so that you see that one is no more than the other or less than the other. So for 60 degrees now, yes, for 60 degrees, notice this is 60 degrees. This is also the 60 degrees. It's the same thing as saying cos C or cos B. Whichever way, because they are the same angle is there. So let me just use this 60 that is there instead of using B or C. That's why I'm using this. So if I know this, cos 60 degrees is cos is adjacent of hypotenuse. So adjacent of this is 1. Then hypotenuse of this is 2. So that means that cos 60 degrees is the same thing as 1 over 2. So you can now very well see that cos 60 degrees is equals to sine 30 degrees, and cos 30 degrees is equals to sine 60 degrees. So notice that 60, that is now, cos 60 is half, sine 30 is half. Now cos 30 is root 3 over 2, and sine 60 is root 3 over 2. And notice that 60 plus 30 in each case, 60 plus 30 in each case gives you 90. 30 plus 60 in each case gives you 90 degrees. That is why we normally say that cos theta is the same thing as saying sine 90 minus theta degrees. And also, you can also say that sine theta is the same thing as saying cos 90 minus theta degrees. So let's see it. So if I have, for example, 30 degrees here, 90 minus 30 is going to, let's say I have the theta that I have here to be 30 for sine. So if I have 30 degrees here, if I do 90 minus 30 is 60, and you can see that cos 60 that I have, because this will now become, this is now going to, see what I mean. Let's say that cos 30 now is having, cos theta here is having 30 degrees. Let's say cos theta here is having 30 degrees. That means theta is 30 degrees. If you carry that theta and put here, 90 minus 30 becomes 60. And you can now see that cos 30 is equals to sine 60. Now let's say that the angle I have here is 60. The angle I have here is 60. Come and do sine 90 minus 60. You now have sine 30. And cos 60 is equals to sine 30. So that is why you always see formulas like this. It's important to note it. So I think that does it for the sine and cos. Now let's do the tan. To get the tan is simply remembering that tan is all about this sine theta over cos theta. So if I want to come here now for tan 60 degrees, for tan 60 degrees, it will simply be all about what is sine 60 degrees and what is cos 60 degrees. So what I will just do, that is why I told you that tan is the same thing as just saying go to the numerator of sine and numerator of cos and take it and do your work, because you can see that the denominator will always be the same long as you are correct. See, this is sine 60 degrees. This is cos 60 degrees. If you like, be thinking too much. Focus on what we are doing. And we want to do tan 60 degrees. That things are equal does not mean you come and be pulling brain around here. We are focusing on 60 degrees. Sin 60 and cos 60. Notice that 2 and 2 are at the denominator. Just take the numerator. So this is going to be root 3 for sine all over 1 for cos. So tan 60 degrees is simply root 3. Very simple. Now what of tan 30 degrees? So tan 30 degrees is simply sine 30 all over cos 30, and sine 30 all over cos 30. You will now see that is the same thing as say numerator sine all over numerator cos, because the denominator of sine and cos will always be the same for any angle you are looking for. So notice that this is sine 30 and this is cos 30. 2 and 2 is the denominator. So just come and say the numerator and the denominator. So which is the same thing as saying 1 all over root 3 and 1 all over root 3. Anything that has to do with roots cannot be at the denominator. So you do times root 3 all over root 3. So that this gives you root 3 over 3. Root 3 over 3. Very simple. So, but if you want to now go to triangle, if you don't want to do it this way, you want to go to triangle, you can still remember that tan theta, 2 is opposite over adjacent. So you can still remember that 2 is opposite, that is tan is opposite over adjacent. So let's go and do now tan 30 from our triangle. So notice opposite, this is 30 degrees. Opposite of 30 degrees is 1. The adjacent is root 3. 1 over root 3, which is what we have here. By the time you put it together, you have root 3 over 3, because roots cannot be at the denominator. Now, for tan 60, opposite over adjacent, opposite of this is root 3. Adjacent, opposite of this is root 3. Yes, opposite for tan 60, opposite over adjacent. So root 3 over 1. You see it? Root 3 over 1, which is the same thing as what? Root 3. So there you have it for that question 4 that says using I don't want to talk about 0 degrees because sine 0 is 0. So that is it. Using an equilateral triangle, show how to get sine 0, cos 0 and tan 0. Another way to do this thing is look at my finger. I can choose to call this. Let me open another page. So I can choose to call this now. This is my finger. I can choose to call this one 30 degrees. Okay, let me draw it. Don't fear. Don't panic. Don't panic. This one is the hand of a giant. So I can choose to call this 0 degrees, 30 degrees. So this will save us the stress instead of doing all those things that we've just suffered ourselves in 60 degrees and 90 degrees. Then I have a formula that I normally use, which is roots all over 4. Roots of everything divided by 4. Now, when I want to do sine 0 degrees, because 0, you cannot be talking about 0 and looking for the signs inside that triangle. The same thing with 90, unless you are taking it that when you are using the triangle, you always take it that adjacent. Anytime you are considering 90 using angle, adjacent becomes 0. This side becomes what it is, should be root 3 or whatever. So, but this is why this one becomes 1. So this is the main way to do it. So I will call this one. If I want to do sine 0 now, when it's sine, I'll be looking this way. When it's cos, I'll be looking this way. So if I want to do this now, I will now say for sine 0, cross this finger. If I cross this finger and look to the left, welcome. Yeah, if I cross this finger and look to the left, you see that I don't have any other finger there. So sine 0 is simply 0. Sine 0 is equals to 0. Now for cos 0, notice that as I'm having this particular finger, which I call 0, so I'm having it down, cancelled out. If I look here, I'm seeing 4 fingers. So if I remove this, I'm seeing 4 fingers. When it's sine, I look this way, if I cross this, I look this way, I see no finger, I call it 0. But when it's sine, when it's cos, if I look this way, I see 4 fingers. So I come and put this here. 4 divided inside this formula. 4 divided by 4 is 1. Root 1 is 1. So cos 0 is 1. Let's go to the next one. This is 30. For 30 now, I'll see that this is simply going to be, if I cross this finger and look left, I'll see 1 finger. And when I look left is sine. I'll come to this equation and put 1. So root 1 over 4 is the same thing as 1 over 2. So cos sine 30 is equals to 1 over 2. While for cos 30 degrees, you see that by the time I cross this finger and look right, how many fingers am I seeing? 1, 2, 3. So anywhere you are, this is 30 now. This way, I cross this one, I'm only looking this way. So if I look this way for cos, I'm seeing 3 fingers. So come to this place, this is our formula, and put 3 here. So you see that this is going to be the same thing as saying root 3 over 4, which is the same thing as root 3 over 2. So cos 30 is the same thing as saying root 3 over 2. Now when I want to do 45, cross this finger. You see that if I cross this finger, then these ones will be on. So if I cross this finger, I'm not seeing 2 to the left, 2 to the right, which means that sine 45 and cos 45 will be the same thing. So if I come here to this, our formula of root everything over 4, put 2, put here, you see that this is going to be that sine 45 is the same thing as looking left, you see 2 fingers, looking right for cos, you see 2 fingers. So it's going to be root 2 over 2. So sine 45 and cos 45 is equals to root 2 over 2. Then for 60, if I cross this finger and look left, notice that I'm now having 1, 2, 3, and looking left means sine. So for 60, if I cross this and look this way and look left, I'm seeing just 3 fingers. So come and put it in this formula. It will now be root 3 over 4, which is the same thing as saying root 3 over 2. So sine 60 is equal to root 3 over 2. While cos 60 is equal to, if I've crossed this finger, this one now, and look right, cos means looking right, how many fingers am I seeing? I'm seeing just 1 on the right. So if I cross this and look this way, I'm seeing just this finger. So which means that it's going to be inside that box 1 over 4, which is the same thing as 1 over 2. Now for 90 degrees, if I look this way left, if I cross this finger, cancel this, and look left, I'm seeing just 1. And looking left means sine. So it means that sine 90 degrees is equals to root 4 over 4, which is the same thing as saying 1, root 1, which is equals to 1. While cos 90 degrees will be equals to, as I've crossed this finger, if I look right, I'm not seeing any other finger. If I cross this out, look this way, there is no finger here. So it means that cos 90 is 0 degrees. So, and please remember that I normally say that if I have a circle, everything up here is the same thing with everything down here. Just that this one is positive y, while this side is negative y. So if I have, so for example, sine 90 to be 1, sine 270 should be equals to minus 1. Always remember this thing for a reason. We'll still get to this, but I just feel like pointing it out because we'll still get to it. So we are using all these questions, the past questions, to answer all the trick questions, so that by the time we finish the 30 questions or 30 something questions there, or 70 questions there, we'll be good to go. So we've answered question 1 and 2 earlier. We just finished question 4. So next we go to question 5.